This video we will cover number 1, what is rate equation, rate constant, K, order of reaction, and the overall order of reaction. We will cover these 4 as number 1. Number 2, I will cover how does increase in temperature affects the rate constant, which is your K, and rate of reaction. Okay, so we will cover these 2 things. Number 1, we shall cover the 4 definition. What is rate equation? Rate equation is the one that I'm highlighting in blue in color now. Okay, so rate equals to K, all right, A and B. Okay, now what is your capital A and capital B? Capital A and capital B is your reactant here. Okay, so the rate depends on the concentration of your reactant, capital A and capital B. Okay, so over here, when your concentration of the reactant increases, therefore, in this mathematical function, so-called your rate equation, when the right-hand side goes up numerically, the rate on the left-hand side also goes up. So this is how your rate, okay, being affected by an increase in concentration. Okay, now, and then this whole rate equation in blue, all right, just tells us, all right, the dependence of the rate of reaction on the concentration of your reactant. So you've just seen how increase in your concentration of your capital A and capital B reactant will increase the rate. Continuing, raised by its appropriate power. Raised by its appropriate power. Now, when you look at the rate equation, they are actually raised, okay, with the power of x and the power of y. Okay, now we do not raise to the number of mole. So as you can see in the general chemical equation, you have A mole of capital A reactant and you have B mole of capital B reactant. So if you want to recall back to your Kc, Kp, or any equilibrium constant, the normal practice is where we will raise to the number of moles. Am I right? But in a rate equation, we do not raise to the number of moles. We will raise to its appropriate power, where we do not know what is the appropriate power, called x, y. Okay, so let me introduce to you what is this appropriate power term called. Okay, this appropriate power term is called your order of reaction. The power is called order of reaction. Let's go to what is order of reaction. Definition, very popular in your past question. It is the power to which a concentration is raised in the rate equation. Okay, I put a star here. Very common in your past year. All right. Now, so we will raise to the appropriate power, also known as we will raise the concentration to the order of reaction. Okay, so we are asked eventually to calculate what is the order of reaction, which is what is your x and y. Okay, yeah, so that is first, what is your rate equation? It's basically like a mathematical formula, all right, to show how rate is being affected by the concentration, which is being raised by its appropriate power, also known as the order of reaction. Now, second thing I have to introduce to you is your K. Your small k, not big K. Capital K is for your equilibrium constant. Okay, this is a small k here. This k is called a rate constant. It's known as the proportionality constant in the rate equation. Okay, just stop here. Will do. Okay, yeah, it's basically a constant. It's just like a KCKP, it's a constant for equilibrium. This is a constant for your rate. So we call this the proportionality constant in the rate equation. Okay, now subsequently, the sentence is just some explanation for it. It's not a definition. Uh, for your information, okay, this is not needed for you to know in your syllabus, but it's good to know. This rate constant called K, it is independent of the reactant concentration. Okay, so let me show you in your formula. This K here, okay, maybe I write in here, rate equals to K. Okay, this K is independent of the concentration. So you can see that the K is alone on its own. The concentration of your capital A and capital B, it is on its own. All right. So therefore, they are not affecting each other. It is independent of the vector of the concentration. But just so you know, this K is actually dependent on the temperature and activation energy. This is extra information. Okay. You don't need to really know this, but like I said, it's good to know that this cake is affected by temperature and activation energy. Okay. In fact, come to think of it, I think you should know. Okay, you should know. Your cake is affected by temperature and activation energy. Why? It's because there is this thing called the Arrhenius equation. Arrhenius equation. Okay, Arrhenius equation is not in your Cambridge syllabus, okay, but you must know that K is dependent on the temperature, okay, and so-called, activation energy. So K equals to AE to the power of REA over RT. Please give me a moment. Let me erase minus EA over RT. Okay, yeah. So this formula, don't memorize this. Okay, this is called the Arrhenius equation, not in the syllabus. But what we can see here is if you want to get a high K mathematically, okay, your temperature must be high and your activation energy or all your activation energy should be low. So when E to the power of a negative small number, the K will be high. If this K is high, which means this K will also be high. And if this K is high in the rate equation, therefore your rate will also be high. Correct or not? So what you can see here is your K is dependent on the temperature in the Arrhenius equation. So actually also got to do with activation energy now. Now you know. Okay, but Arrhenius equation, please don't memorize the formula. But I want you all to know that the K rate constant is dependent on temperature and activation energy, which eventually does affect your rate of reaction. So that is your rate constant, known as the proportionality constant in the rate equation. Now the last one, very easy. What is the overall order of reaction? So mathematically, you sum up the power, which is x and y. Okay, so you just take x plus y, that would be the overall order of reaction. All right, I give you a couple of few basics first. So these are the four terms I would like to address and what is their definition. Now, second, indirectly, I also address how does increase in temperature affects, number one, your rate constant, number two, the rate of reaction. This one you have to know in your syllabus. Okay, now when you have an increase in temperature, okay, your rate constant will increase in bracket via the Arrhenius equation. Okay, in bracket means don't need to know this equation. You just need to say that increased temperature will affect the rate constant. Okay, and of course, increased temperature will also affect, all right, or increase the rate of reaction. So it's actually a subsequent process. Okay, yeah. So I rewrite the whole thing again. In the Arrhenius equation, please don't memorize this unless you would like to do it. Okay, when an increase in temperature, your K will increase. You just press your calculator, e to the power of negative small number. Your K will be big. Okay, now when this K is big, Therefore, it means this K is also big inside the rate equation. Okay, yeah. Therefore, your rate of reaction will also increase. That is all you need to know for your syllabus. All right. Now, I want to take you through to one answer question, a very simple exercise here. Okay. Let's look at the very recent one. Okay, called the summer 2341 question 3. Okay, yeah. Now, we just do some question, all right, which is quite basic. So they gave us this equation over here. Okay, first question asks, what is meant by order of reaction? Correct? Huh? So hence, just now, we have learned that order of reaction is the power to which a reactant concentration is raised in the rate equation. Okay, definition quite popular. Now, then number 2, okay, can you see this is your rate equation given? They have conveniently write the rate equation for us for the above equation here. Okay, yeah, so they have convenient write for us. So we can see that they already have the appropriate power, all right, for the equation. Now, first, please look at the difference. You have 1 mole of iodate, okay? Yes, I know it's power to 1, but it's power to 1 not because it is 1 mole, okay? Now then, if you see there is 6 mole of proton ions, but you realize that the power is square, correct? Now then you have 5 moles of iodide ion, and you realize the power is also square, correct? So like I said, you cannot power to the number of moles. You can raise to appropriate power known as the order of reaction. And of course, you will be asked to calculate what is the order of reaction in other questions. So, but this question, they already provided for you. Okay. Now, we are asked to complete the table 3.2. Number 1, what is the order of reaction with respect to IO3? You just look at the power that's being raised by your iodate, IO3 minus. Since over here is power to 1, therefore this is first order. Okay, first order. Power to 1 also known as first order. You can answer first order or you can write 1. Number 2, what is the order of reaction with respect to H plus? So since your H plus is power to 2, which is square, you can write here second order, or you can put a 2, either one. Number 3, what is the order of reaction with respect to iodide ion? There's a square here, the power is being raised, so you can answer second order or 2. Now, therefore, last question, what is the overall order of reaction? Overall order is the summation of all the orders, hence the answer is 5. That's it. Okay, so I hope this video can tell you what is rate equation, what is rate constant, what is order of reaction, what is the overall order of reaction, and the second one is how does your increasing temperature increases rate constant and eventually increases the rate. Okay. I would like to add on, which is to find the units of the rate constant. Okay, even though it's not asked in this question. Okay, yeah, I'll just use this exercise to help you to find the unit for your rate constant. Now, first, find questioner the unit of rate constant, which is your K. Now, everybody, you have to refer back to your rate equation given on top. Now, rate over here, the unit is mole per dm cube per second. Now, K is the unit that we want to determine. Okay. Now, iodate. Iodate is a concentration. The unit is mole per dm cube. Since it's power to 1, we power to 1. H plus is also concentration, so mole per dm cube. Square means you also square the unit. Iodide, mole per dm cube. Square, you also square. So can I take this mole per dm cube on the left and cancel out with the mole per diem cube on the right? Yes. Okay, so what is your unit of K? So your K now, you have to shift everything on the right hand side to the left, all right? You will become mole negative 4 dm positive 12, okay, with an S minus 1. Okay, so there are total mole negative 4 because positive is on the right, you shift to the left is negative 4. So that is your unit of your rate constant. You have to find the unit of the rate constant according to the rate equation. So every rate equation will have a different unit for the rate constant. Okay,